Hello, and welcome to another video from Ellensburg Amplifier Repair and Service. Today we have a Class AB amplifier that has been requested to make a video on. It is a Konaki. Let's see here. That's upside down for you guys. Let's try this. Let's see here. There it is. Konaki KO3648M. Some weird numbers on that. It's an interesting little amplifier design. You can see it on the bigger camera or the wider camera. So it is just a standard Class AB amplifier that I am currently working on. So it does have some heat signatures here, which is real typical for the resistors used to supply the voltage, auxiliary voltage for the preamp. A lot of amps, you'll see these things just kind of be cooked. In my opinion, they're kind of rated a little low, wattage-wise, to dissipate the power that they're wanting to dissipate. So I'm just going to remove those and put some metal film resistors in, because these have drifted in value. I don't want to say a lot, but they have drifted a little bit in value. So I'm going to go ahead and replace them. Because they did drift in value. You know, our favorite thing that everyone does is bend the leads. Good old FR301 makes quick work of desoldering components off your boards. So there's the two resistors. And they stood them up off the board, so I'm going to do the same thing. So you can kind of see one is slightly burnt. 500 and, what is that? Green, blue, 540? What is blue? I don't have those things memorized. 560 ohms. So I do have two 560 ohm metal film resistors here that we're gonna put in their place. Not saying I'm not a fan of carbon composite resistors, but I did a lot of restoration work on old vacuum tube testers, and if there's one thing I learned about the carbon resistors is they will drift. They tend to drift, in my opinion, a little bit more than a metal film. So I just figured I'd point that out. That's just my opinion. I think they do drift quite substantially more when it comes to temperature. As carbons heat up, they'll drift. The FR301 is still running, so I can solder these back into place. I'm just going to bend the leads just like they did in the factory. I'm setting the resistor up off the board just like they did. So as you can see, they are pulled up off the board. This is just some preventive work that I'm doing right now on this amplifier. I want to make sure the preamp stays as healthy as possible when it comes to the voltages present. So just to help prevent any future preamp failures, I'm just going to replace the resistors. All right, and I have, you can see on the board here, I have marked 35 and 36. They use TIP 35s on one side and TIP 36s on the other. So there you got your NPN and your PNP transistors. This does have a drive issue drive. I mean, we use the word drive in amplifier, so typically drive is for your Class D amps. But I don't have any. I don't have any pre-drivers. Well, I do. Something's not functioning right on this, I should say. One driver will heat up, one will stay cold. So with the thermal imager, so that tells me right off the bat I know I have an issue in the driver section of the output stage here. The TIP 35 and 36s are not shorted. They're showing okay. So as of right now, I'm not too worried about those. But I'm going to replace the components that are driving these TIP 35 and 36s. I'm showing the same signals on both only because I do believe that's going to be part of the feedback circuit that's open. But the one having at least a thermal signature and one not having a thermal signature at all can point me to a few things. We need to make sure that we have both positive and negative rail present. This is a Class AB amplifier. So I'm going to just go ahead and hook up some power here. And we're going to find out what's going on. Find the remote path. And as you can see, we do get some blue LEDs. Okay. And while it's running, I'm just going to check and see what I'm dropping here. 26.13 volts. 41 and 26. Well, hold on here. Woo-wee. I will tell you right now that I will bet money that we have a faulty preamp is what it is. One of these is going to be smoking hot. Oof. That's when I probably should have had the old thermal imager out. So let me make sure I didn't drift in value. Oh, it did quite a bit because it got super hot. So that probably is telling me that I have a preamp problem. Let me see if I can get this thing to settle out here. What were these 500 and... Whoops. $476. Why is that taking so long? There we go. So this one is still good. 553. And not so much. We do have a problem here. What do you think failed on us? The Zener diode? Probably. Aha. Okay. Well, if you guys can hear the beep of the meter. So this is why I was getting not a very good signal over here, is because we do have a shorted Zener diode, which is bad. You know why that's bad? Is because if you were to check the Zener, it is directly connected to your preamp. So whatever voltage is getting passed across this Zener is unfortunately going to your preamp, all your ICs in the preamp. That's so the only thing we can really do is hope and pray that we're gonna fire this thing back up and that all the, these are probably 07 or 072s. What are these? These are the 4558s. 455. So Yeah, so they're using the 4558 op amps here. So hopefully that did not damage it, because I did read 40 some odd volts being dropped here, so, because that shorted. So hopefully we're okay. Hopefully. We're going to find out. I am going to be right back with you guys because I have a customer coming to drop an amp off. I'll be right back with you. All right, here we go. Back with this amp. All right, so I replaced the two resistors and I replaced the Zener diode. The Zener diode was shorted previously, which I do believe was the problem with the amplifier. So now we're dropping 15. So we got 15.8 volts. What are we dropping across that resistor? So we're dropping 25 volts across that resistor. All right. Now, let's see if we can find ourselves a faulty... if you notice here too, I did remove all of the drivers for the TIP 35 and 36s. One of these is going to be faulty, or maybe not. The preamp could have been the problem by not having, and that's negative voltage too, by the way, so by not having any negative voltage available. So, what shall we do? Let me double check and make sure that this... Not looking good. Okay. Let's see here. What time is it? 1:30. Perfect. 649. 649. 210.
210.
Mm-hmm. All right, let's see here. Back. That is the back. That is the back. 649, 667, 667. Is this going to work? You know, I'm not sure. We're going to find out. The 1266s, I'm going to go ahead and replace 1277. Where's my 1266s? 1266. 1266. The 1266 equivalent is going to be the 1015. 1266 equivalent. Dun, dun, dun. I think I'm going to go ahead and replace excuse me, that 649 also. So I'm going to go ahead and replace the 649 with a new 649. The 667. And then the 669, we're going to go ahead and replace that one also. The 669 is over here. And then I'm gonna the 1266s. The 667. I don't think I have the 667. Well, I'm gonna have to dig for them. I'll be right back with you guys. Well, all right. Well, I guess it'd help if I hit record, but I did get the drivers. I just replaced them. So these drivers are replaced. Let me cut the leads off. All right, no leads sticking out. Do a little clean up on the flux. Just a little bit. I'll come back through with the toothbrush and clean it all up. I just want to make sure that I don't have any solder bridges or that I missed any solder joints. All right, looking good, looking good. Let's go ahead and see what this Zener diode is doing. We're going to go ahead and fire up the thermal camera also, because I'm going to take a thermal image of the driver section here. All right, what do we got? A little bit of heat here just from the soldering. Looking good. So let's see what heats up on me. Looking pretty decent. That negative rail Zener diode, I would probably always question its lifespan, because it does run significantly warm compared to the positive rail. So that's something that you'd keep an eye on over time. So that's the negative rail resistor. Here's the positive rail resistor. So you can tell that it's been cooking for quite a while. So we're going to go ahead and introduce a little bit of a signal here, because we want to kind of see what this thing is doing. Oh yeah. So as I'm throwing things on the floor here. All right. That shorted Zener was most likely the cause and failure of this amplifier, because now I have a, well, it's a kind of square wave on the scope here. Let's go down to a 1 volt input signal. So the bass now, the bass is showing a good excuse me, a good signal. Excellent, excellent. And it's a big old clipped out signal because there is no feedback on it. So, but I'm just making sure that I do have the good 51 hertz signal there. I don't have it up on the screen for you guys because if I turn the scope on, my camera will start to glitch out. So really odd. But I do have these normal square wave now that I would expect to see on the bass for the TIP35 and TIP36s. Boy, yeah, that Zener runs just extremely hot. Yeah, probably a that's a tough one to do there. That's just the way they're dropping that voltage. So let's go ahead and we're going to install the TIP 35s and 36 back into place. Power off. Pull my RCA jacks out. Disconnect my power. So the 35s are on your positive rail. Now I just gotta be able to see them. So here's the 35. There's the 35. There's the 36. 30. Yeah, it says 36. It's a 35. 35 and 36. 35. There we go. Okay. TIP 35s. And these mount really odd, so we're just going to go ahead and I'm going to try to keep them the same height as they did at the factory. And I will do them all at one time. Excellent. Looking great. All right, let's try this thing up. Woo! Dropped my remote lead everywhere. All right, let's see here. Okay. Let's see what this thing's doing. Oh, a sine wave, of course. Yep, sine wave, sine wave. We have it. Let me just make sure nothing is heating up. Nope. All right, well, let me get the, now that we have feedback going, I don't have a full clipped out signal, so I can turn up my input voltage. Signal input voltage. To see what's going on here. There it is, a nice, good, clean, just an absolute clean sine wave on the output section. So, looks good, looks good. I think we're going to leave it at that. Oh, it's not dropping. Okay, now that we've added some load to this, we're not dropping near as much. We're not getting near as hot on that Zener diode. Don't think we are. I'm using the human field test here. No, I would consider that normal. Perfect. So we do have a sine wave. Let me just show you, verified that we do. I'm going to go ahead and fire up the scope. You might start to see the camera start to get a little glitchy, but let's go ahead and show you this sine wave that I am seeing. Maybe. All right, there you go. Scope, upper left-hand corner. 50 hertz signal going in at 2 volts on the preamp input signal. And there's your sine wave. And as you can see, there's no distortion, no crossover distortion, which you'd see in the center of that sine wave if something was truly out. You don't see any ringing, you don't see any spikes. Nice, clean, smooth sine wave. And there just goes my camera, just like I had said. So that was the repair of this amplifier. It was a faulty Zener diode which I do believe failed because the resistor, the carbon composite resistor, had drifted far enough in value that affected the voltage of this, which turned around and probably could have damaged the driver. I doubt it. I think it just shorted the Zener out. So when you short the Zener out, you don't have any negative rail, because the negative rail is getting shorted to the secondary ground common, and the secondary common is not bonded on this amplifier. Let me turn off my scope. Otherwise, it probably, when you lose that Zener, shorts the rail to secondary common, which then goes through a resistor that shorts out the resistor. It's usually, I think, a 1K resistor. I've seen jumpers, I've seen all sorts of things used for the bonding of the secondary common to the negative input terminal. So this doesn't have that. There is no resistance between the power incoming ground and the RC shield. It's completely wide open. I do believe. I'm going to double check that just to make sure I'm giving them correct information, but I do believe there is nothing between. Yeah, there's nothing. Ground. Absolutely nothing. So there's, if you have an issue, it would never really show in a way to shut the amplifier down. So that's on the design. That's just how this is designed. So we did get this repaired. Signal's working. I'll get this amplifier put back together. I'll replace all the thermal paste, any gap pad or thermal insulators that need to be replaced, put it through some load testing, and get it back to the owner. So thank you guys for watching. If you have any questions, please leave them down below and I will get to them as soon as I can. And always feel free to ask me any questions. And visit me, www.ellensburgamplifier.com. We'll see you guys in the next one. Oh, and of course, stay safe. Keep your fingers out of the rails. See you in the next one.